So today's all about review. So we are going to review logs, review exponential functions, and we are going to start with number 1, which asks us to use the properties of logarithms to expand the following expressions. Okay, really quick, let's review expressions or properties of logs. So we want to make sure we're able to condense or expand logs when we need to. So a couple properties are going to help us. The first that we are going to see and use looks like this. If we have two values within a log that are being multiplied together, I can expand those out as log base a of x plus log base a of y. So each value goes within a new log. The base of that log is the same for both of them. And then know that this goes in both directions. So if it's adding together two logs, same base, I can write it as a single log where they're multiplied. All right, next property, division. Log base a of x divided by y can be rewritten, expanded as log base a of x minus log base a of y. So very similar to multiplication, except I'm subtracting the two logs. And the top value, the numerator, would be the first term, the denominator, the second. All right, and the last one, if I have log base a of x raised to some power, I can bring down that exponent and multiply it by just the log base a of x. Okay, cool. So let's see how we use these. So in this first example, the natural log x to the 7th w square root z of z times y. So I have a lot of stuff being multiplied. So I'm going to start with this first property, where I can rewrite them as expanding out using addition. So this would expand to natural log of x to the 7th plus natural log of w, notice it's natural log again, plus natural log, and because the z and y are stuck under the square root right now, we're going to write it as the one term under the root. Okay, next, to simplify natural log of x to the 7th, I'm going to use that third property. So I'm going to bring down the 7 in front of the natural log. Natural log of w stays the same. And this last one, I'm going to expand it by first rewriting the square root as an exponent. So this isn't a log property, but it's so good to know. If you have a value under a root, and it doesn't matter what the root is, let's call it root b, I can rewrite it as an exponent by taking the power that's under the root divided by the power, divided by the actual root itself. So for example, the square root of x can be written as x to the 1/2. So even though x doesn't have an exponent, we assume it to be 1. So I'm going to do that here, except it's going to be zy to the 1/2. Okay, then I'm going to continue on. I'm going to leave these two alone for now in the front because they're pretty much expanded. They are good to go. This next one has an exponent, so I'm going to bring the 1/2 down in front of the natural log. And then because these guys are being multiplied, I'm going to rewrite it as natural log z plus natural log y. Notice sometimes I write it in parentheses, sometimes I don't. It doesn't matter. The thing that does matter is that 1/2 in the previous step was being multiplied by natural log of z times y. So when I expand the z and the y into their own natural logs, I still want to include the 1/2. So I actually want to put brackets around that whole natural log of z plus natural log of y, so that that whole expansion is getting multiplied by the 1/2. Last step, add the first two terms. And here's my answer.